Myself, Dr. G. Nandini, Assistant Professor from the Department of Mathematics, SNS College of Technology. Today, we are going to see the topic Understanding Eigenvalues and Eigenvector in Design Thinking. So, design thinking concept, we have been using this concept in SNS institutions. So, design thinking concept has 5 levels of steps. The first one is empathize, second one define, third one ideate, fourth one prototype, fifth one is test. So first, beginning into the topic, we have to do the empathize, why we need to understand this topic, then define the problem and find the solution, and giving idea is the ideate. Finally, we will go to the prototype and final step is the testing. So this presentation dives into the concept of eigenvalues. So eigenvalue highlights its significance as a significance across various disciplines such as mathematics, physics and engineering. So eigenvalues as its role, important and vital role in mathematics, physics, engineering, etc. By employing design thinking, we aim to clarify the understanding of eigenvalue and explore their diverse application, ensuring a comprehensive grasp of this fundamental concepts. So this is our empathize part. By empathizing what is the need to read the eigenvalue and understand the eigenvalue and explore their application, we need to understand the eigenvalues. So first, let us define what is the eigenvalue. Eigenvalue or scalar value that arise from linear transformation in vector spaces representing how much a given vector is stretched or compressed during the transformation. So this is the definition of eigenvalue. We find eigenvalue for a matrix, and this helps us in physics for stretching or compression during the transformation from one field to another. The mathematic representation for a linear transformation represented by a matrix A, that is a matrix A, we have the eigenvalue. We usually define eigenvalue of a matrix by lambda. So lambda represents the eigenvalue, satisfies the equations. So the equation is AV equal to lambda V, where V is the corresponding eigenvector. So for any matrix, we can find the lambda values, that is eigenvalue, such that AV equal to lambda V. Here V stands for the eigenvector. Importance in linear algebra. This eigenvalue plays a critical role in understanding the properties of matrix, including stability, oscillation modes and system behavior in various applications. So this is the empathize point. We need to read the eigenvalue so that we can understand the properties of matrix. So by understanding these property, it can be used for stability, oscillation modes and system behavior in various applications. So finally, we empathize what is the purpose for reading eigenvalue, define the eigenvalue, and finally what is the purpose for an idea of eigenvalue help us. The application of eigenvalue help in the dimensionality reduction by identifying principal component for what purpose, that is to maximize the variance in the data. So this is the purpose for the eigenvalue, the applications. It helps very much in dimensionality reduction by identifying the principal component. We usually define the principal component as PCF that maximize the variance in the data. For mechanical system, eigenvalue determines the nature frequency of vibrating system, curricle of engineering designs to avoid resonance. In physics, eigenvalue also plays a vital role in physics. Eigenvalue represent observer quantities such as energy level in quantum system. Calculating characteristic polynomial. The eigenvalue of matters can be found by solving the characteristic equation obtained from determinant A minus lambda I equal to 0, where I is the identity matrix. In numerical methods, for large matrices, numerical methods like QR algorithm or power iteration are employed to approximate the eigenvalue effectively. Another application is modern software tools like MATLAB and Python library provide built-in function to compute eigenvalue, making it accessible for practical applications. Finally, eigenvalue can be for real and complex number, indicating stability or oscillating behavior. The algebraic multiplicity refers to how many times an eigenvalue appears, affecting the count of eigenvector. So finally, we understood the process and why to understand the eigenvalue through the design thinking concept. Thank you.